Hello, check. Hello, hello.
Now we are starting with the experimental demonstrations.
Hello. Very good afternoon to all of you. Myself Rashmi. I'm doing research under the supervision of Professor R.K. Sharma, who is the coordinator of Green Chemistry Network Center in India. Today my talk on the green chemistry, basically the principle of green chemistry. Although sir gives you lots of knowledge of green chemistry, let's talk about what is the definition of green chemistry. Very brief definition of green chemistry is to minimize or reduce the waste material and hazards, waste energy, and the cost of chemical reaction. Please move forward.
Arisha?
It is, we all know that the history of green chemistry. History of green chemistry is introduced in 1991 by the Professor Paul Anastas, the father of green chemistry. His mission is to find an alternative process for those involved more hazardous substance and conditions. Next up, these are the 12 principles of green chemistry. I will discuss each and every principle one by one in my next slides. But the important thing here to notice that why we care about green chemistry. Why everybody is here to attend this seminar. Anyone? Why it's important? Think.
Answer.
Our mother nature should like our environment should be safe. It should not be get adulterated.
Yes, ma'am, absolutely, ma'am. It is first of all for student. It is very important for you because it is in your syllabus, green chemistry. So you have to know what is the green chemistry principles. Next is we know all that the chemistry creates lots of problems like contamination, toxicity, exposure of chemicals, energy consumption, depletion of raw material, waste production, and all this. Chemistry creates all these problems. And we are the chemists. We have to solve these problems of chemistry. And it's just possible because of green chemistry. That's why we have to focus on green chemistry. The first principle of green chemistry is to waste prevention. We have to minimize waste. To calculate the waste prevention, it is a E factor. E factor is the mass of the waste upon the mass of the product. It means if we do chemical reaction, we take reactant A plus B and form C, and we prepare only C. No side product, no byproduct. We want only product. Okay, and from E factor we can calculate if more is a E factor means more is a waste produced, and if E factor is high, it means there is it's a dirty chemistry. Like we can see oil refining has very less E factor as compared to pharmaceutical, where the pharmaceuticals has very high E factor. It's 25 to 100 E factor. It means pharmaceuticals has more scope for green chemistry. It is the most dirtiest chemistry in India. Next principle is atom economy. Atom economy means to convert all the reactants into product. We can calculate atom economy by this formula: the mass of atom in the desired product upon the mass of an atom in the reactant. It also means that all the reactants should convert into product. No side product, no byproduct. We need only product in 100% yield. Sorry. It's an example of calculate the atom economy. Here's the equation: carbon plus 2 moles of hydrogen and to form carbon dioxide and 2 moles of hydrogen. In this equation, our desired product is hydrogen. So we take the mass of a hydrogen. There is a 2 moles, so there is a 4 gram of hydrogen, and upon the
48.
total mass of a reactant. This is a total mass of reactant, and when we multiply these to 100, we get this. This is the atom economy in this particular equation. This is how we can calculate atom economy. Higher the atom economy means there is a no side product, and the lower atom economy means when there is a waste over there. It's another example of atom economy where it's a two method to prepare these reactions. Here is the 25% of atom economy, and here is the 76% of atom economy where we use catalyst. If we use catalyst, there is a high percentage of atom economy. Next principle is less hazardous synthesis and the safe chemical designing. Here is a synthetic route of ibuprofen. It is a one route, it's a classical route where we use multiple steps to form a product. And we use lots of waste over there. HCl is produced simultaneously, and aluminum is produced. In the next route, which is a greener route, there is 3 steps to prepare a product. Means basic means that we have to use less number of preparation of product. Next is benign solvents and the auxiliary. It means we have to use less toxic solvent in our chemical reaction. Earlier it was a myth that to do a chemical reaction we need a solvent. It was a myth, but now lots of chemical reaction can be done in a solvent-less reactions. It only possible because of green chemistry. Here's an example of solvent-less reaction where we take solid A and solid B and grind it and form a solid C. And this solvent selective guidelines. It is a guideline from the Green Chemistry Network Center that the preferred solvent are there. These are green in color. We have to use water, acetone, ethanol, propanol, all the alcohols in our solvent. We do not use these DMF, methyl formamide and DMSO and all that because they are harmful, carcinogenic and all that. In next, 6th principle is energy efficient. In all the chemical reaction, we need heating, cooling, stirring, distillation and all that. It requires energy requirement, means electricity, and from electricity we need to burn fossil fuels, and from fossil fuel generate carbon dioxide in the atmosphere. Ultimately, global warming is a big problem. So in green chemistry, we use all the chemical reaction at room temperature. Next is 7th principle is use of renewable feedstock. Our reactant should be renewable, means we can use multiple times, not biodegradable reactant we should use. Next is reduce the use of derivative. We have to prepare that reaction or mechanism or scheme which has less derivative products. It means unnecessary derivatization should be avoided whenever possible. The next is 9th principle is catalysis. We all know about the catalysis. It enhances the rate of the reaction and also the yield. Next, 10th principle is design for degradation. We should not use halogenative moieties, some heterocyclic and quaternary carbon, tertiary amines. We should avoid all these moieties. Chemical products should be designed so that at the end of their function they do not persist in our environment and instead break down into smaller pieces or substances. Next is 11th principle is development real-time analysis for pollution prevention. Real-time analysis means we have to monitor all the chemical reaction in a on the spot. For example, when coal is burned in industrial boiler, sulfur dioxide is formed, and if the temperature of the boiler is too high, a large amount of sulfur dioxide will generate it. And using real-time monitoring, the amount of sulfur dioxide generated can be measured all the time. All the time means on the spot we are measuring the concentration of sulfur dioxide. Once it reached an unexpected level, an alarming signal will be generated. Then the temperature will be lowered immediately. It means the real-time monitoring is important in all the chemical setup. The 12th and the last principle of green chemistry is inherent safe wet chemistry. It is a two method to prepare this product. One is we prepare methylamine and phosgene and form methyl isocyanide, and we take naphthol and form this product. And another is this root. We can see that it is a red mark because methyl isocyanate is very harmful, and because if we this is a greener method. If Union Carbide India use the green chemistry, then the Bhopal tragedy will not occur. Bhopal tragedy has not occurred in India. The green methodology for nanoparticles. For the synthesis of nanoparticle, everyone please, it is important, it is in your course how to prepare nanoparticle through a greener approach. Conventionally reducing agent, we have lithium aluminum hydride, sodium borohydride, hydrogen, zinc amalgam, and diborane, tin iron compounds. These are the conventional reducing agent. But we are using greener methodology to prepare nanoparticles. So we will use natural reducing agent like tea tree, lemon, rosemary, clove. Clove means long. We can prepare from a long to nanoparticle. And soya bean, sprout, tea leaves, and neem extract. The next is preparation of silver nanoparticle using green methodology. We take plant extract and silver nitride and then mix it and stir it. Then we form silver nanoparticles. What is happening in the reaction? Actually, silver nanoparticle in iron form, and because from the plant's extract, in plants extract many antioxidants are there, and it reduces silver nitride into silver atom, and these silver atom combine and form a cluster, and this cluster grow into nanoparticles. This is the 10 image of silver nanoparticles. It is prepared by greener methodology. You can also prepare it in your lab also.
Have you prepared the silver particles in your lab?
We prepared gold nanoparticle. We will perform experiment for gold nanoparticle. We do not prepare in our lab, but it is reported in journals, various journals. This is a green methodology for iron nanoparticles. We can use neem extract, even microwave, solvent, green solvent, reducing sugar, tea leaves. We can prepare nanoparticles from these methods. The next is experiment of the green chemistry. Today we will perform 4 types of experiment. First will be a biodiesel, and it will be done by Shriparna Datta. And second experiment is synthesis of manganese AK, and it will be done by Radhika Gupta. And synthesis of gold nanoparticle will be done by Aditi Sharma. And the colorimetry analysis with a color picker app will be done by Manvi Yadav. This is a team of our Green Chemistry Network Center. Here's your Anil sir, right there, and this is thank you.
वहाँ पे लाइट जलाने को लाइट जला लो। हाँ, साथ
स्टार्टिंग की स्टार्टिंग ये सेकंड बस
Hello.
ब्लू ब्लू क्यों? ये क्या होता है?
Good afternoon, everyone. I'm sure everyone must be excited for this session. Since morning, you have been hearing a lot about what is green chemistry, but none of us have actually seen, I don't know how many of you have actually performed any green chemistry experiments. But today, in this experimental setup, experimental demonstration, we shall see. It's audible? Okay. So we shall be performing green chemistry experiments. So the first experiment that we take up for today's session is biodiesel. Okay. So okay. So the first experiment that we take up today is preparation of biodiesel using vegetable oil. So how many of you know what biodiesels actually are? Anyone? Can anyone answer? If anyone is aware of this term biodiesel. Okay. So firstly I shall provide a brief background about what biodiesels are. You know, today one of the major problems that our Earth, that the planet is facing is problems due to air pollution, which are arising primarily due to the emission from fossil fuels like diesel and petrol, which on which our transportation system is heavily dependent upon. So they release these emissions, work as pollutants, and they cause major health problems like respiratory diseases, etc. A lot of health issues are caused. So this is a very serious problem, you know. So to combat this problem, we need to develop other alternative fuel sources, and thanks to the chemists who have been able to develop one such alternative, which is called as biodiesel. Now what biodiesel actually is? You know, biodiesel is a clean burning fuel which is produced from renewable sources of energy. Renewable sources of energy like what exactly? From vegetable oils or normal cooking oil or any form of oil. Any form of oil like canola, soya, etc., mustard. You can use that oil and simply convert it into a biodiesel. And each one of you sitting over here can do so. And we'll see how to do that. Right? So biodiesels are basically obtained from crops. The vegetable oil obtained from crops such as canola, soya, etc. by chemically changing the fats and oils present through a trans-esterification reaction. Actually, you know what happens is the crops contain vegetable oil. The vegetable oil contains triacyl glycerol. Triacyl glycerol is basically broken down into simple esters, and glycerol is obtained as a side product in the presence of alcohol and KOH, which is a base over here. So this is a simple trans-esterification reaction through which we are able to obtain biodiesel. So the methyl esters that we obtain function as biodiesel. So the process is very simple. Take a vegetable oil, add methanol, KOH, and you are able to synthesize biodiesel. And it is actually that simple. Now, what are the advantages of biodiesel over the conventional sources of conventional sources like diesel? The first very advantage is that biodiesels are derived from renewable sources of energy, like plant crops, etc., which will grow again and again. On the other hand, the diesel is produced from crude oil. The crude, as you know, the sources of crude oil are actually limited, and if the current rate of, the current rate at which we are using, if it continues, then soon we'll become a resource deficit. So obviously, in comparison to the crude oil, biodiesel is a far more better alternative. Then secondly, biodiesel does not contain any sulfur, so it will not lead to any sulfur emission, unlike diesel and other crude oil and other sources of, petrol, etc. The third advantage is that biodiesel breaks down quickly in the environment, that is, it is biodegradable, breaks down quickly in the environment, and unlike the problem that is associated with oil, like the accidental spills that occur, so we can avoid that using biodiesel. And moreover, unlike the other diesel sources which lead to a lot of greenhouse emission, biodiesel of course will also lead to that. But because biodiesel is obtained from crops, the vegetable oil which are obtained from the crops, so basically those crops will reabsorb back the CO2 from the atmosphere. So you know the balance between balance of CO2 is maintained in the atmosphere because of this. So these are some of the major benefits of biodiesel, which is why we have also prepared it, and we shall now begin with the experimental demonstration of biodiesel. So you can obviously use any source of oil. You know, घर पे आप जो oil use करते हो, the waste oil which you generally discard, you can even use that and prepare biodiesel. And I'm sure a lot of you will want to try this. So after going through the experimental demonstration, surely try it in your labs. Okay, so I'll begin the stepwise narration of how biodiesels are obtained. The very first step, what we do is, we are going to use mustard oil for this purpose. You can use any source of oil, of course. So we take 4.5 gram of mustard oil in a clean round bottom flask, which contains a magnetic bead. She has already placed the round bottom flask on the stirrer. Are you all able to see? If not, then please come forward. I think the ones who are sitting behind, they won't be able to see it visually. Okay, so if it's fine, then we'll continue. Then to this oil, 4.5 gram of oil, we add 1 ml methanol slowly while the solution is being stirred. Then followed by addition of 2 drops of 10 molar KOH. So basically you have to prepare 10 molar KOH for this purpose. And keep stirring the solution for 15 minutes. You know, we find that the moment the base and the alcohol is added, the color change starts occurring. From a pale yellow colored mustard oil solution, you obtain a thick, bright yellow colored solution. It is, you can see it visually as well. So since, because of the time constraint, we'll keep stirring the solution for 15 minutes while we have already prepared this the reaction mixture that we obtain after 15 minutes has already been prepared by us, and basically that reaction mixture which you prepare, you'll transfer it into a centrifuge tube. That's the centrifuge tube, and centrifuge it for 5 minutes. Okay, place it in a centrifuge machine and centrifuge it for 5 minutes. You know what will happen next? We'll actually end up with 2 different layers. You know, so this is the reaction mixture from the RB which we had obtained. We have transferred that into a centrifuge tube. We have centrifuged this for 5 minutes. We end up with 2 layers. Biodiesel on the top. It's up here, you can see it visually as well and as well as in the slide. And the lower layer contains the glycerol, obviously, which is the side product that you have obtained. And any bit of starting material which is left will be left behind in the lower layer.
उधर से
We are concerned with the uppermost layer. So, in the next step, what we are going to do is, we are going to extract the uppermost layer. You can simply take an autopipette if you use autopipettes, or you can simply take it with the help of a pipette sucker.
समझ आ रहा है
Pipette out the uppermost layer and place it in another centrifuge tube.
यार दिखा तो तेरा नहीं समझ
So what we are doing is, basically we are extracting the uppermost layer, because that is what contains the biodiesel. So once we have extracted the uppermost layer, we get the crude biodiesel. Now biodiesel will obviously contain other contaminants and impurities as well. So we need to purify this biodiesel. Now how the purification will be done will be explained in the next step. You know, we'll take the centrifuge tube containing the uppermost layer, to which we'll add 1 ml distilled water. Okay? Add 1 ml distilled water to this, and you need to shake the solution well till both the layers are actually miscible, till the solution you achieve a miscible solution. Then again place it in a centrifuge tube, centrifuge machine, and centrifuge for 5 minutes. After centrifuging it for 5 minutes, we'll again obtain 2 layers. You know, the uppermost layer will contain the biodiesel, and the lower layer is the aqueous layer that contains the water. So why are we using water in this case? Basically, any aqueous impurity which is present in your reaction mixture will go into the water, and that water will discard. Now what we'll do is we'll extract the uppermost layer again. Because the purification step needs to be done with a lot of care, and it is really important to purify the biodiesel to achieve a good quality biodiesel. So, we'll again take the uppermost layer. You can take it in an RB, or you can take it in a beaker, or you can take it in another centrifuge tube. And then we add 2 ml of ethyl acetate into the solution. So, as you can see, the uppermost layer that we had extracted, to that we have added 2 ml ethyl acetate. Why ethyl acetate? Because biodiesel basically consists of organic substances which will be soluble in an organic solvent. So we have chosen ethyl acetate, which is an organic solvent, for this purpose. So we have basically taken 2 ml ethyl acetate into it, and we again shake this solution well. Okay? Shake the solution well, and then we'll dry the solution. You know how can we dry the solution? You must have all heard about sodium sulfate. It's a drying agent which absorbs moisture. So what we'll do is, in a funnel, as you can see over here, we place a small cotton, very small cotton on the funnel, and then we add 1 or 2 grams of sodium sulfate. Okay? Then the resultant reaction mixture, which contains ethyl acetate, is then poured over onto the funnel, and ultimately whatever moisture or impurities, whatever moisture was present, will be absorbed by the sodium sulfate. And in the funnel, in the conical flask, we obtain the biodiesel. This process should actually be repeated 2 or 3 times to obtain a purified biodiesel. Right? So we have already done that, and we'll finally show you the sample of biodiesel. That's the sample of biodiesel which is also shown in the slide. Right? So this is how we prepare the biodiesel. The process is quite simple. I'll just recapitulate. What you need to do is, firstly we'll just prepare the reaction mixture. How? By taking vegetable oil, add methanol, add KOH, stir it for some time, okay, till 15 minutes. You can visually see the color change has occurred because we have kept stirring it for almost 10 minutes. So the color change has actually occurred. and till a thick bright yellow colored solution is obtained. Now that solution which you obtain needs to be centrifuged, and the uppermost layer which will contain the biodiesel needs to be purified. For the purification step, you will take distilled water and ethyl acetate simultaneously one by one and purify your sample. So at the end we end up with biodiesel. Now how do you know that your biodiesel has actually got formed or not? So we need to characterize our biodiesel. So that we can do using these tests which I have mentioned in the slide. So firstly, the first step is go for IR analysis. Take the IR spectrum of your biodiesel and obviously observe the peaks. The C double bond O peak of the ester moiety will be present at around 1740 and a sp3CH stretch which will be present around within 2800 to 3000 centimeter inverse. Okay, so this sp3CH stretch will occur primarily for the biodiesel only. Okay. After going for the IR analysis, you can carry out the pH. pH test is quite simple. You know the pH of your final biodiesel should be 7. So what we do is we take few drops of biodiesel, add distilled water, shake it well. Then place 1 drop on your pH strip and check the pH of your solution. So the pH should be around 7. That is neutral because it's a neutral substance, right? Then we go for the freezing point test. Actually, biodiesels, you know, they have a property to freeze at lower temperature. So this vial which I had shown you previously, which we have prepared, you can as it is take this vial and keep it in your refrigerator. Keep it for 10 to 15 minutes and you will find that if your biodiesel has actually got formed, it will gel at lower temperatures. It will form like a gel-like substance. And in case the biodiesel still contains some ethyl acetate, that gel formation will not occur. So that indicates that you have to again evaporate the ethyl acetate to dryness. So you have to actually evaporate off the ethyl acetate. So and finally we go for the combustion test which we have performed in our lab. If possible, we'll show. Okay, so I'll just narrate it through how we perform the combustion test. We'll take three separate watch glasses. In each of the watch glasses, firstly we'll label the watch glasses. The first sample is blank. The second is contains oil. The third contains biodiesel. Place equal volumes of cotton in each of the 3 watch glasses, as you can see over here. So we have taken equal amounts of cotton in each of the 3 watch glasses. Okay, and in the second sample, we have added 10 drops of oil. In the third sample, we have added 10 drops of biodiesel. And we ignite, and the first one is obviously blank. The cotton is, you do not add anything to it. That's the blank sample. Ignite all the 3 samples at the same time and observe what happens. You know, you'll observe that biodiesel burns with a cleaner flame. It has a higher burning efficiency, so it will not generate any smoke or soot at the end. And we have actually observed that we obtain a very clean fuel. We have tried seeing this. So, and at the end, we do not observe any smoke or soot. And it's better if you can compare the biodiesel with normal diesel. You will I have taken this picture from internet. And you will see that the biodiesel does not generate any smoke or soot after burning, whereas the diesel generates smoke, the soot which is observed right at the top, because of the impurities, large amount of impurities which are present in the diesel. So we have compared the efficiency of the biodiesel. And finally, all of us, you know, in countries like USA and Canada, they are all switching over to biodiesel because of its, you know, brilliant properties, and because of the fact that you need just a renewable source of energy. I mean, you can simply take the oil, the discarded oil which goes to waste, you can take that and utilize it. So you do not need any, I mean, it's a renewable form of energy, it does not pollute, and moreover, in our countries also we have a lot of feedstocks of various oils, but in particularly in USA, you know, they have feedstock of soya bean crops, because of which, you know, 73% of their fuel production is being supplied by biodiesel. So it's a much more cleaner alternative. It's less polluting, non-toxic, biodegradable. It recycles back CO2 into the atmosphere, and it's also domestically produced. So that's the end of this presentation.
Very good afternoon to all of you. Hello friends, I am Radhika and the experiment which I will be dictating will be performed by my friend Rashmi. As we have seen the biodiesel preparation with the help of green methods, I am here to prepare a complex which is the manganese egg cake. The full name is tris acetyl acetonate 2 manganese 3 complex using a greener method. This picture is the actual structure of the manganese egg cake complex, and this is the solid black crystal shiny compound which we have prepared. Before going into the experimental details and the applications that why we need to prepare this, we actually have some prerequisite knowledge about what kind of metal we are taking, what is the source of the metal we are taking, and the ligand. Here we will be preparing a manganese complex. For this we need KMNO4 and the ligand. Ligand is actually, we know that we have a metal, and the metal which it belongs to a D block element. We have a ligand which will donate its electron pairs into the vacant d orbitals of the manganese element. The ligand which we are using is acetyl acetonate. Acetyl acetonate is actually derived from a compound called acetyl acetone, which is an organic compound, and this in solution exists in two tautomeric forms. Here we can see the two tautomeric forms of acetyl acetone. One is the keto form, keto because it has two ketonic groups present at second position and fifth position. It is in equilibrium with its enol form. Enol contains one double bond at the second position, and at the fourth position OH is present. This is actually in resonance between these two structures. Now, this experiment, this is actually in presence of a basic medium. This loses one of the protons and will exist in this eke form. This is actually the acetyl acetonate ion, anion, which will be used as ligand. This is a bidentate ligand. Why bidentate? Because it has two positions from which it can coordinate its lone pair of electrons into the d orbitals of the manganese. So, actually why we need to prepare this complex is, this is widely used, there are many applications of this complex, but as of now I am explaining only two. It is used as NMR shift reagent, which you will be studying when you will be studying the NMR, and this is used as a catalyst. As we all have been listening from since morning, that catalysis is one of the principles of green chemistry. I have shown two equations here, two reactions. These reactions have been performed by my friend. This is the oxidation of the aryl compounds, aryl halides, which is at the second position, and this is oxidized in presence of the manganese eke complex into the corresponding ketone. We can also use this manganese eke complex for the oxidation of the secondary alcohols into the ketonic part. All these reaction conditions are very environmental friendly. We are using only hydrogen peroxide as the oxidizing agent, and ethanol is also green solvent as explained by Rashmi, and another reaction is actually solventless. So you can see that with the help of this complex, which is also will be soon performed by a greener method, we can prepare the corresponding oxidation products very easily. So, we will be requiring only potassium permanganate. It is very well present in your laboratory, and acetyl acetone. Acetyl acetone contains some impurities. Therefore, before going into the experiment, we need to distill it off, and we have already distilled the acetyl acetone. We will be requiring 23.19 ml of distilled acetyl acetone and distilled water. And the other materials are also very simple. We are using a steam bath, a beaker, a glass rod for stirring, a funnel for the filtration purpose, a Whatman filter paper for filtration, and cold water for the purification of the product. The procedure is very simple. We'll take 5 gram of the potassium permanganate and we'll dissolve it in a minimum amount of distilled water. We'll do this by steaming over a water bath. This requires, because we know that potassium permanganate, you all have studied that it is not a primary standard. Can somebody tell me the reasons that why it is not used as a primary standard? There are so many reasons, but the basic reason is that for primary standard you need to know the exact and precise amount of the standard which you are adding. But potassium permanganate, it contains slight amount of manganese dioxide, due to which when we dissolve it in water, some precipitate will occur at the end. But we need a very homogeneous solution, therefore we'll filter it off to remove the traces of manganese oxide which will be precipitating at the last. We'll filter it off with the help of a funnel and using the Whatman filter paper. We can add some more water if it doesn't dissolve properly. Here we have not kept exactly the steaming water bath due to the lack of time, but in our lab we have actually performed it, and after getting the solution, we'll add 23.19 ml of acetyl acetone to the above solution which we'll be getting after the filtration process. So we'll add this much amount of acetyl acetone. We have added acetyl acetone, and then we'll stir the solution constantly with the help of a glass rod. As you can see in this picture also, we have kept the water bath and we have kept the beaker with acetyl acetone and potassium permanganate. As soon as we add acetyl acetone, it will become brownish in color, and we'll be stirring it continuously for another 15 minutes. You will be seeing that somewhat foam will occur, but that doesn't matter much. And after 15 minutes, we'll allow the solution to cool. We'll keep on stirring for 15 minutes and then we'll take it off and put it for another 10 minutes so that it will cool. After 10 minutes, we'll filter the mixture and we'll wash it with cold water, and we can dry the product so obtained by keeping it overnight or for some hour in a vacuum oven. After that, you will see that very beautiful black shiny crystals will occur that we have already prepared and kept it in the vial. After the session, you can come and see it. But you will not be appreciating me much because you didn't know that what are the conventional methods, what were the conventional methods with which we prepare the acetyl acetone in older days. Earlier there were two approaches. First approach was using the acid-base concept. As I earlier told you that acetyl acetone, it loses its proton in the presence of a base, and then the corresponding anion will be forming. So earlier the complex was synthesized using air or chlorine oxidation of a basic solution of, earlier the source which we used was manganese 2+ ion in the presence of acetyl acetone. But because chlorine was used as an oxidizing agent, therefore the alkali which we are using in the basic form, it will affect the ion product, and also it will get contaminated by the chloride ions. Therefore, we move to another approach. Another approach is again the oxidation method, in which manganese 2+ will be converted into manganese 3+ in the complex. In this case, we used KMnO4 as the oxidizing agent in presence of acetyl acetone. But for this method to be executed, we need a pH of approximately 5, which will only be regulated when we add a large amount of sodium acetate. So the disadvantage in this method is that a large addition of sodium acetate is required to maintain the pH at approximately 5, and we know that sodium acetate solution can be used as a buffer solution. So it will keep the pH at approximately 5. Now, the chemistry that is involved in our method is that we have found out from our repeated experimentation that acetyl-acetone is itself used as a reducing agent. Here we are using a reducing agent, and in earlier experiments we have used a oxidizing agent because the source was manganese 2+. So we need to convert manganese 2+ into manganese 3+. But here the manganese source is KMnO4, which is in +7 oxidation state. So we need to reduce it down. Therefore we are using a reducing agent, and we are not adding anything new. We are using one of our reactant as the reducing agent, which is acetyl-acetone. So it is actually responsible for the reduction of manganese 7 to manganese 3. Here we are using excess of acetyl-acetone because from Le-Chatelier principle, see, these experiments are very basic, and this requires only your knowledge up to that you have gained in class 12. You know what is Le-Chatelier principle. We are using KMnO4 plus acetyl-acetone. So if excess of acetyl-acetone is used, it will be shifting the equilibrium towards the right hand side. So therefore, the acetyl-acetone is, excess of acetyl-acetone is the driving force for the reaction. Next, it doesn't involve any kind of buffer to maintain pH, because it has been recorded that as soon as we add acetyl-acetone in the solution, the pH automatically makes up the pH to approximately 5. So we are not using anything new. So the advantages that we have adopted in this green method is that we didn't require any buffer. The complex can be prepared in less than actually 1 hour. The process is economical and no excess reagents are used. We doesn't use any other reagent, and the process provides a high quality product in a very good yield. So these are the advantages. I hope you appreciated the green method, and thank you so much. One thing that I forgot to tell you, that in the similar manner we have prepared in which we have prepared manganese eke complex, we can similarly obtain the copper eke complex and the iron eke complex, which are also equally green method to produce. Thank you.
Good evening everyone. Here I am Aditi Sharma dictating about preparation of gold nanoparticles using greener approach, and performing my friend Suparna Datta. We here used green approach, any green materials for the preparation of gold nanoparticles. Here is a pictorial diagram. Here we use tea leaves for the preparation of gold nanoparticles. Basic requirements are: the chemicals required: green tea leaves, auric chloride, that is gold solution, apparatus, conical flask, pipette, graduated pipette, but we used micro pipettes, stirrer, funnel and standard flask. Firstly, we weigh 200 mg of tea leaves in a watch glass. Here we use Darjeeling tea leaves. 200 mg and transfer it to a conical flask containing 12 ml distilled water. And stir it for 15 minutes. We have already prepared this solution as lack of time. This is termed as stock solution. And we have filtered the solution and termed as stock solution. Then we have used Whatman filter paper to filter the solution. Then we have taken 6 ml of filtrate in a conical flask and place on a stir bar 6 ml of filtrate. You all are listening about gold nanoparticles since morning. Do you know its advantages?
Cancer therapy.
Any advantage of gold nanoparticles? Sensors. Any other?
आवाज लग जाएगी ना मजा लग
Anybody knows that gold nanoparticles are present in our blood. So it is also helpful in blood cancer. It's a medicinal effect of gold nanoparticles which we can use in the blood cancer therapy.
हेलो मैं हूँ, बताओ कौन बोल रहा है?
Then we stir it for 15 minutes and whip it out.
15 आधे घंटे में करेगा, 15-20 मिनट में, 15-20, हाँ मतलब लग जाए.
Auric chloride solution. Auric chloride solution is contaminating or it put a stain on your clothes, on your body. So be very careful for this.
अभी यहाँ से फ्री हो गया हूँ ना.
Put a drop of auric chloride and color changes instantly. It changed to ruby red color. As you can see here.
तो आएंगे नहीं क्या?
I don't know it's visible
पक्का?
or not.
It's visible.
तो बैठे गया हूँ. ओके.
Is it visible?
कलर चाहिए.
Actually, the more and more you keep stirring it, the color
Changing.
intensifies. So, no, it has changed, and if you keep,
You can see here in the picture.
if we keep stirring it further, the color will change, and we'll show what we have obtained in our lab. The color becomes.
The color becomes ruby red. Then you can see here. Visible to everyone? Yes. Next there is a shot. In the shot, we can explain we have taken tea leaves, then put in the conical flask with containing 12 ml distilled water, and then we stir it for 15 minutes and filter it, and then the filtrate, we take 6 ml of filtrate and dip it out auric chloride and added 1 or 2 drop of auric chloride and then stir it and the color changes to ruby red color. This is the green approach for the formation of gold nanoparticles. Next, we have taken stock solutions for the color formation of gold nanoparticles. So we have also performed that there is any change into the concentration of tea leaves or the reducing agent or the gold solutions. So we prepared 3 solutions of stock solutions, that is 1%, 5% and 10. And we measured the color changes, and you can see here. And we have also performed the UV visible spectra. You can differentiate between the three solutions: 1%, 5%, and 10%. This is a basic change in the peaks. Why this change in the peaks? Because of particle size, particle distance, and there is a basic change in the colors. And this is explained by surface plasmonic theory. Any questions about it?
How is characterized gold particle?
With UV visible.
With UV visible only.
Relation between particle size and absorbance in UV.
As the size increases, the absorbance decreases.
And you can see the color change also occurring. As the concentration is decreasing, we can see that the color, becomes less intense. You can see this is the one which is prepared with the 10% stock solution. This is the one wherein we have used 5% of the stock solution.
5% means what?
5 ml of stock solution and remaining 95%.
Please repeat. 5 ml of
No,
Stock solution that we have prepared.
the stock solution which we had prepared, in which we had taken 200 mg of tea leaves and 12 ml
plus-
distilled water.
Right.
We had added. We prepared that solution, and that's the stock solution.
There's
the
a stock solution.
Yeah, stock solution of tea that we consider as 100%. So then we'll make 3 different dilutions: 10%, 5%, and 1%.
Okay.
So by the simple formula, M1 V1 is equal to M2 V2. So we'll just prepare 3 different stock solutions, and then we'll repeat this process, and these are the color changes that are happening. As ma'am, the concentration of that stock solution is decreasing, the color intensity is reducing, and she has already explained that.
Thank you.
Yeah, see, one more thing, the color of the solution turned into ruby red.
As we started, the color changes to ruby red. You can see here.
That indicates the formation of
You have
gold
gold
nanoparticles.
nanoparticles.
So it's simply using tea, you have been able to prepare gold nanoparticles. So that's a green approach.
Have you applied these gold particles in any application? Yes, ma'am.
Yeah, I'm going to demonstrate the application. And silver nanoparticles.
Now you will see the applications of gold nanoparticles. That is very interesting. We are using some interesting formulas.
कौन सा एप्लीकेशन है तुमने?
हो गया
Good evening everyone, I'm Manvi and I'll be talking on colorimetric analysis using Color Picker app. Now, before moving to Color Picker app, I would like to ask a question to all of you. Are you using any app in your smartphones? I think almost everyone has a smartphone. Yes? Okay, so name any 5 apps you use in daily life. That's 1. Second? One by one. Okay, one is WhatsApp, other one is? Hi. Okay, Facebook. Instagram. Now come to some more apps. Okay, OLX is a good app. Then you have Rovers, and you have many more apps, right?
PixArt
But how many of you use scientific apps?
But have you ever thought that you can do the chemical analysis using an app? Do you have any idea about this? So today today we are going to present an experiment which is based on a color picker app. Now color picker से तो यही लगता है यार कुछ फोटो वोटो से related कुछ होगा, but actually हम लोग यही कर रहे हैं. This is what we are going to do. This is what we are going to click, and from the photograph itself we are going to find out the intensities and finally the absorbance. So before moving forward, I would like to discuss the basics of Lambert-Beer's law. Have you ever heard about Lambert-Beer's law? What is the relation? What is there in Lambert-Beer's law? Anybody can tell me? Intensity and amplitude. Please stand up and answer. Stand up. It's okay. That's okay. Everyone is student over here. I guess less number of teachers are there. Stand up. That's okay.
खड़ा हो जा भाई.
All right. So basically, Lambert-Beer's law. According to Lambert-Beer's law, when a monochromatic beam of light passes through a transparent container, this is the container. Okay. This is a transparent container in which we keep our sample, and when the monochromatic beam of light passes through this sample, there are some particles present in the sample. This is a colloidal solution which will absorb the light coming from here, and then the intensity of the light will decrease. So basically, I0 stands for the intensity of the incident light, and I is the intensity of the transmitted light. From this particular thing, from I0 and I1, you can calculate the absorbance. Absorbance is also directly proportional to the concentration as well as to the path length. Now, concentration of the sample. Why are we saying that absorbance is directly proportional to the concentration of the sample? What do you think? If a sample with more concentration is kept inside the sample tube, definitely the absorbance is going to be very high, right? Yes. Okay. And it also depends upon the length. Path